Hey guys, Sebastian from Madrigal here. I'm making a video game as a solo indie developer. The game is called Traction Point, and it's a vehicular exploration game with puzzle elements. And I'm making the game using a self-made engine and tools. If that sounds interesting, there's a ton of videos and live stream boards on the channel, so be sure to check that out. Maybe even subscribe. Now recently I've been working very hard on the demo for the game to be able to release it for you guys. And as part of that, I've done a bunch of audio work. Now, I am a relative noob when it comes to audio, game audio design. And so it's been a whole journey learning this stuff, but a very fun one. And last year I started working on my own game audio authoring and design tool, which is this thing that you see here called Timbre. Now, I could have easily used Fmod or Wise or any of the other existing solutions to do this. But I wanted to make my own since I really wanted to understand how the system works. And also, I wanted to make my own so that I can release it to you guys, so that you can potentially later on mod the game, add your own sounds, do all of that fun stuff. Now, Timbre is not terribly different from Fmod or Wise or any of the other systems. Basically, you have a bunch of events here. This is just a test project that we're looking at now. And an event is essentially a unit of something in the audio world, something that the game can instantiate, such as a sound effect or a piece of music or whatever. So here we have perhaps the simplest Timbre event you can imagine. We have an alert wave file. When we start the event, we play the audio in the alert wave file. It sounds like this. Super simple. The game can instantiate this, create many instances of it if it wants to. We can have parameters that it can change on the fly to change things like volume and pitch, all of that good stuff. We can apply filters, as you can see. All of that. And it's working really nice and well. But this is not all that you need to actually do audio design for a game. You also need a way to edit audio, chop wave files that you might have bought as part of a bundle or online or even recorded using a microphone. Chop them up into pieces, apply filters, effects, trim them, all of that good stuff. And you also need a way to manage your files, so you know which ones you actually need. Here on the right side we have the assets folder for this particular project. We have a bunch of things in here. For example, we have the same alert wave file here as we already have in the event. We can switch this out for a metal hit one if we want to, and now it sounds like that instead of the alert one. Pretty basic stuff. But this library can get really quite large. A single game project can have hundreds, if not thousands, of these wave files here. You need a way to efficiently edit them, keep track of them, and all of that. And I have chosen, at least for the time being, to use REAPER to do that. So REAPER, even though I use this as an integrated audio editor, and I'll talk about the integration in a bit, use it as an audio editor essentially. This thing is a full-blown DAW or digital audio workstation, which means that you can do music production, all kinds of audio design with this thing. It's almost like a small recording studio and mixing studio in software form. So it should be flexible enough to do basically anything I want. And flexible really is the word here, because this thing is probably the most customizable program that I've ever used. I have like this action list here. These are things that you can do. You can see that there are like so many of them. You can chain these things together, you can add new scripts, you can do all kinds of things, add shortcuts for them, and so on. Now, I'm very much a noob when it comes to this program, as well as audio design in general, so do let me know in the comments below if I do something really stupid. But I have spent a little bit of time lately working on an integration between Timbre and REAPER, and I now have a workflow which I'm kind of happy with. I think it's kind of elegant and nice. So I figured today we're going to design a sound effect, implement it in Timbre, design it here in Reaper, and I'll show you what I have. Before we do that though, you can see up here in the top right corner that we're using Wasapi. This is a sound API found in Windows. Currently it is what I use because I need to reroute the audio to you guys so that you can hear it in this video. Normally I use my audio interface through ASIO, which is much faster, but my audio interface is basic, so I wasn't able to reroute the audio to this recording from it. So I have to use Wasapi for that. And occasionally Reaper gets annoyed with Wasapi being slow, so it displays a gray box in the middle of the screen. If you see that appearing, that's what that's about. Alright, with that out of the way, let's have a look here. We have a sound temp folder on the desktop. And this is really just a folder where I have some sounds that I might want to work with later. And here we have an electric motor hospital bed wave file. Sounds like this. So it's a motor that starts up, runs for some time, and then shuts down at the end. And we're going to take this sound and make it reactive so that we can start and shut down the motor from the game conceptually, but from Timbre, and have the sounds react accordingly. So let's get started with that. I'm going to create a new project here. I'm going to use my time-based template. I'll tell you more about that in a second. So we're here in the asset folder. We have SFX, sound effects, and test assets. So it's the same thing that we have here. So let's go into sound effects and create electric motor as the Reaper project file name. This is important. Copy all media into project directory. So leave that checked. And also create subdirectory. And there we go. So now if we... actually one thing I want to do, I want to create something called a pseudo master. So this is a workflow that I've learned from a really awesome article on doing sound design in Reaper, which I will link below in the description, so you can read that for yourself. There's all kinds of handy tips in there if you want to do some audio design for games in Reaper. And that article suggests creating a pseudo master here, so you don't have to mess around with the actual master. Instead have this here, which is more flexible. Let's make it a folder, and then we can just drag this electric motor hospital bed into the project. It gets nested under the pseudo master, and here we now have the actual sound, as you can hear. So that's nice. Okay. Now we need to chop this up into pieces, and we'll start with the intro, the startup of this. And we'll probably want to basically, I'm gonna turn off the snapping for a bit. We'll want to keep a little bit of this engine or this motor sound here, but not that much. So let's cut it there. Split that into two different items. I'm gonna remove this crossfade here. So it's completely seamless still here, at least, because the parts are just sitting exactly next to each other. So the next thing that we'll want to do is do the same thing basically for the end. And I think this is probably where we will want to cut it. Let's see. So the motor sound ends around here. I don't think I want that in the shutdown sound. I can basically just take it right before this click here. So that will be the shutdown portion of the file. And one very nice thing about Reaper here is that we can now non-destructively edit this. So I made a copy of this end here, and we can play it if we want to. Look, sounds the same, obviously, but we can still bring back like an earlier portion of this, which is really nice. And this may be like a very basic thing that's present in all of the serious sound design tools, but still, it's very nice that it's here. And you can also scroll this audio here within this actual sort of window that we have going. All right, so now we have sort of a beginning and an end. So what about this looping middle part then? Let's turn snapping back on. So there's a little bit of clinking and clonking going on in the latter part of this, so let's just cut that away completely. I think I will want to probably bring this over slightly. Still getting the hang of this whole snapping thing here, but basically I want this to loop. And you can see that it's not quite looping. So let's try to make it seamlessly loop. I'm gonna bring it over like this and place it there. And then we'll go here and we'll do a reverse, because I don't think there's a hotkey for this, but we'll do toggle take reverse. So now it's reversed. This latter part, that is. Oh, we'll want to actually extend this so that it plays to the very end there, right? Like so. And this kind of works. There's a little bit of kind of noise going on here. So what if I actually just make that a bit shorter, and again I'll bring it over, and again I'll do the reverse thing. I should probably map that to some button somewhere. We can even do like a crossfade if we want to, like this. Yeah, there's a little bit of noise there as well. Let's cut that just ever so slightly back, like so, and then do this thing. Now this should be the final one. I'm hoping. Yeah, that's much nicer. All right, so now it should loop seamlessly. And it does. So that's nice. Okay, so now we can bring all of these guys together. Let's take these, move them. Actually, what I'm going to do, another thing I'm going to do first before I move these, is put them into regions. So we have this thing. I'm going to hit, is it Shift R? And that makes this into a region. Actually, maybe I should make this the first region. Like so. Shift R, that's a region. And I'm pretty sure you can do this more easily, but that is now also a region. And then finally we have this, which we also want to put into a region. It should go until there. Region. So 1, 2, and 3. And now we can move these very easily, and they all snap together nicely. And now if we play the whole thing back, we should have a seamless sort of cycle of this electric motor. Let's have a listen. Pretty nice. At least I can't hear any terrible pops or other nastiness going on. All right, so now we have basically the three parts that we want to export or render into WAV files so that Timbre can use them. And this is where we would now normally go into File and Render, and we get greeted by this monstrosity. I may be sounding a little negative. I am not. This is awesome that you get this much control over what you actually render. However, I feel like if you're doing small incremental tweaks to your work, then when you want to re-render things, this is too much information. You want to set up things sort of once and then kind of just re-render things more easily. I do know that you don't actually have to go through this dialog to do rendering, and you can do all kinds of really nice things with there's something called like a render matrix or whatever it is. Can't remember exactly where it is right now. Routing matrix maybe. Region render. This is the one I'm thinking about. So you can see your regions here, and you can render them by ticking these boxes, and you get all of the things nicely rendered out for you. However, you're still rendering to WAV files, and those WAV files then come up here in your asset list, and then you have to remember, which ones are the actual rendered ones, which ones are the source files, and so on. And you can, of course, do that if you have a sensible naming convention. But for me, in this very particular case, the WAV files that we render for this, they're really only used so that you can then plug them into Timbre. You're not really interested in that file. You just want the data to be plugged into Timbre somehow. And this is where my integration now comes in. So if you give these regions a name, you can call this start up. We can call this motor loop. And we can call this shut down, right? Now we have names for all of these things. And we could have more regions, of course, if we wanted to, just for organizational purposes. But you can also use these regions to let Timbre know that, hey, we actually want this to be a wave. So I'm going to prefix this with wave : startup, wave motor loop, and wave shut down. So let's save this project and let's switch into Timbre. Still haven't rendered anything. If we now do a refresh assets, we can see here that we have our electric motor folder here and the project. electricmotor.rpp. We can also see the media file here. This is now the full file, which is not cut up into sections, which we can bring in and use as an asset in one of our events if we wanted to, but we probably don't want to, so let's not do that, but we can see it here. Let's create a new event for this sound effect. We'll call this electric motor, like this. And now let's put in some nodes for us here. When the event starts, we want this to trigger, and we want to play some audio, like so. So what do we now put into this audio source here? Well, we can actually just drag this electric motor REAPER project directly into our node. And we can see that re-render needed, or render needed in this case, because we haven't rendered it ever. So let's do that. We can just right click here and select render from within Timbre itself. And what you will see is that REAPER will sort of flash open, will render its things, and then it will close. And now, suddenly, we have our three sections here. The sections that we prefixed with wave : actually are now rendered, and we can use them. You can see here in the output that we rendered the REAPER project into a temp folder, and we created something called a wave bundle. This is something that's just, I've just completely made this up. It's not like a REAPER term. A wave bundle is basically just like a file that contains multiple wave files. You can see that we have 3 wave files here. And now we can just plug this in like so. And we have our startup, we have our shutdown, and we have our motor loop. Just like that. And what is nice about this is that we have the media files here that actually make this REAPER project work, right? These are the media files that are referenced by this project. But we don't actually see the rendered stuff here. We just click render and they magically show up in the project. If we make a change here now, go back to the REAPER file, I'm just going to make a change 1, 2, 3, startup 1, 2, 3, and I'll save the project, Control S, and go back here, and I re-render this. Again, it's going to flash open and then go away. Like so. We can see that now magically this is called startup 1, 2, 3. So it's communicating all of the rendered things automatically to the Timbre project. That's very nice. You don't have to think about, oh, where's this rendered file and where's the source file and all of that, because you really only see the source files here. So you might be wondering, okay, where is the rendered content then? If we go have a look at the folder again, electric motor, you can see here we have RPP wave bundle. And this is really just an interchange format in a sense. This is quite literally just the wave files one after the other with a little bit of header just to be able to locate those in the data. And this is basically like throwaway stuff basically. As long as you have REAPER on your machine, you can always regenerate these guys, and Timbre can always use them. So it's just indexing into which wave do you actually want to use. So I feel like this is really nice because it makes it very obvious. Okay, this is the rendered stuff. We don't really need to touch that. Timbre is smart enough to only use the wave data that is actually used by an event when you're actually building the Timbre project. So here it would, for example, use the second one. The 2 other ones would be left out. So pretty cool. But it still makes sense to actually put these into source control, because if someone doesn't have REAPER, they can still use this as long as they have the wave bundle files. All right, so let's, as a last thing, let's implement this this effect here to make sure that it actually works, right? So we want to start with the startup sound, like this, and then we want to continue with the looping version of the looping section, motor loop, and is it looping to true? And now if we play this, it will just basically never end. But you can hear that there's a very slight pause between the first one and the second one, right? It's not completely seamless. And that has to do with the fact that this audio file ends, and only once it is actually finished do we start the next one. So I don't actually have seamless queuing of sounds working in Timbre yet. I do have seamless looping, which is how this loops seamlessly, but I don't have seamless queuing of one sound and then the next. Now, a small hack that can be done is to trigger this play audio just ever so slightly before this thing stops, so we can get the length out of the wave, and we can delay it, but not quite the amount of the length, but just ever so slightly less. But that can be kind of annoying to have to do everywhere, so I have a composite node which handles it for us, which we can use instead. This is really just an implementation detail of how Timbre works more than anything else. So this is the composite node. So it's a node made out of other nodes, the inputs and the outputs. We have a normal play audio node inside of this. We get the audio length. We subtract an early continue value. So this is something that's supposed to be very, very, very small. Then we have a delay. And we delay, when the delay has passed, we call this early continue through this early continue pin instead of the finished pin. So let's do that instead. And this is kind of a hack until I have proper seamless playback of multiple sounds. So we just plug audio source into there. We plug the length into the audio length. And then we need to do something about that early continue value. So we'll use a float here. We'll set this to something pretty small, like 0.025 or something, early continue, like this. Oh, except I put it on the wrong node. My bad. Take that away. Just put it here. It's this one that's supposed to be played like this, and then we want the next sound to actually be triggered early, right? So not at the finished one, but actually the early continue is what we will use to play the looping sound. So motor loop, plug that in there just like before. That's fine. And then we need the float one again. And early continue, 0.025. I think that's probably fine. Let's have a listen. So if you know there's an imperfection there, you can sort of hear something, but it's kind of small. And you can play around with this value if you want to. I don't know if it makes any sense. It's sort of a temporary hack anyway. All right. So now we have the startup and the looping sound working. If we press the stop here now, this will, first of all, it will never end until we do something. If we press the stop here, it will just immediately stop. It won't play the shutdown sound. And that's kind of obvious in some sense because we haven't actually played that. But let's bring it in. And select it from the drop-down. We can't plug it in like this because this looping sound here actually never finishes. And we also can't somehow plug it into the stop because the stop button will just stop the event from running at all. So the way we need to do this is with a signal. So we need to have a signal that we call shut down, for example. Or we can call it stop. It doesn't really matter what we call it. But yeah, if we have a signal called shutdown, we will get a button up here, also called shutdown. And the game would then be sending this signal to the event, to the running event instance when something happens in the code. But we can simulate it here by just clicking this button. It does the same thing as the game. All right, so when we shut down, first of all, if we're playing this sound, we want to stop it. We want to play this sound, and we also want to stop that sound. All right, let's have a listen to this. So if we now press the stop button, it will still just stop completely. If we press this sound, oh, and that's because we copy-pasted this, so we had the looping flag there. Let's do that again. Click shut down, and look at that. So it keeps running for a little while. And again, we can query this this REAPER project for like how long is the length of this shutdown thing here. And we can even print it. So format print. For example, when we do the shutdown length is something, and we just plug that in there. So now when we press the shutdown button, it reports that it is 0.62. But of course, if we wanted to, we can make some change to this end, and we can do that by, let's see if I can do this now without breaking this project, this beautiful project of ours. We can, for example, extend this a little more. I'll extend this region as well. And now if I double click this, should be able to listen to this. So now it has a little bit of that engine sound or that motor sound in there before it ends. And really the only thing we need to do now is save this and re-render it. And this probably won't sound super nice now because I'm not sure if that motor sound flows nicely into this motor sound at the end. But at least we should see this shutdown length is be something a little larger now. Yeah, because now it's 1 second. And you can even hear the end of the motor sound being a little different. But yeah, that's the idea. And now all of this is neatly packaged up into an RPP wave bundle. If we make any changes, we quite simply do a re-render from here. I still want to make the rendering a bit more flexible so that I can actually adjust values about how it gets rendered. You can select the runtime format here, the format that you actually want Timbre to put these things into when you export them to the game. So you can select if they need to be originals, so WAV files essentially, or if you want to compress them as OGG Vorbis or MP3. But that's basically the extent of it. Currently, whatever you mark up here using regions in Reaper, that is what you will get. And of course, nothing actually forces you to use this integration. You can still have a Reaper project. You can even have it here inside of the Timbre asset folder, so it shows up here. But you can just do the rendering by hand, and you don't need to actually generate the wave bundle if you don't want to. It's all up to you. So basically, this is what I have had for you today. If you have any questions or suggestions or feedback on this workflow, then by all means let me know. I'm still learning about this whole audio business myself. And we'll see how far this takes me. Pretty sure I'm gonna have to make some changes. That's always how it goes, but that remains to be seen. Anyway, I hope this was interesting. Be sure to like, subscribe, do all of the YouTube jazz, and I'll see you in the next video. Have a nice one. Bye.